Hello, our topic is about enhancing digital payment system security, a blockchain-based framework with multi-factor authentication and quantum-resistant cryptography. So coming to the introduction and problem, so we have digital payments are everywhere, as you can see nowadays. Lots of UPI payments, online transactions, all the digital payments have become a cornerstone of modern economic activities, but this growth has created new security risks. So, like eroding trust, weak security measures led to a lack of user trust in digital payment system. Key vulnerables are traditional system face like major concerns like data breaches and fraudulent activities, and there is the need for stronger security like there is a critical need for robust security frameworks in order to protect user data from misuse. So we have proposed a solution like an integrated approach, so like a framework that combines multiple technologies to address digital payment security, and we have introduced blockchain into it, a decentralized tamper-resistant ledger that secures transactions and reduces single point of failure. As we have distributed ledger concept in blockchain, it provides security. So multi-factor authentication, it uses multiple verification methods with facial recognition as the primary tool to prevent the unauthorized access, and we have quantum resistant cryptography which prepares the system for future threats from quantum computing by using advanced cryptographic algorithms. So AI-driven smart contracts like it enables the real-time transaction monitoring and fraud detection. Coming to the key contribution, a new two-step trust system developed where blockchain securely stores the user data by protecting against unauthorized changes. Integration of advanced technologies like the research implements quantum resistant cryptography, homomorphic encryption, and AI-driven smart contracts to enhance security. And a new app like the study introduces a prototype application that resolves customer problems, boosts the public confidence in virtual payments. So it is comprehensive, it provides comprehensive evaluation. So we have used various sampling approaches and technical evaluations to test the system's reliability and effectiveness. So coming to the research methodology, we have different phases, three phases: qualitative research. We have examined existing studies to identify security challenges and evaluate blockchain as a solution. In phase two, prototype development, built a practical blockchain-based digital wallet prototype using MFA multi-factor authentication with facial recognition. Phase three, qualitative quantitative research. We have used convenience and judgmental sampling to collect empirical data on performance, usability, and user acceptance. This is our system architecture. As you can see, there are different components. So it is a multi-layered design. The system is composed of four layers: user interface, application logic, blockchain, and data persistence. The core components, which we briefly explain the role of each layer and how they interact to ensure an end-to-end security and traceability. So this is the technical framework consists of blockchain platform. The prototype uses a consortium blockchain model based on a hyperledger fabric chosen for its modularity and fine-grained access control. Quantum resistant cryptography. To future-proof the framework, we integrated lattice-based encryption schemes like crystals, dilithium for signatures, and Kerber for key encapsulation. Hybrid key management we have used. The system pairs classical cryptographic algorithms with quantum safe ones to ensure backward compatible. Next, we have evaluation metrics. The key metrics we evaluated the system based on transaction throughput, the number of transactions per second, and consensus latency, the time delay for transaction confirmation, cryptographic overhead, the additional processing costs from using hybrid post quantum encryption, authentication success rate, the percentage of successful multi-factor authentication validation, system resource utilization like CPU and memory usage during the peak loads. We have done some unit time system testing. These are the results. Unit testing success, all individual components including blockchain transaction authentication and facial recognition operated as expected with no functional errors detected. And we have come across facial recognition accuracy, which achieved a 98.6% true positive rate during testing. In system level performance, the throughput is average 220 transactions per second, and consensus latency averaged 1.84 seconds. The peak load coming to the integrity, the system achieved a 100% detection rate for unauthorized ledger modifications. Coming to the quantum resistant performance. So as we can see in the graph, the minimal performance impact, the evolution showed a minimal trade off in performance when using hybrid post quantum cryptography. Throughput, coming to the throughput, average throughput was only slightly reduced from 232 transactions to 240 transactions per second. So coming to the latency, consensus latency only increased marginally from 1.72 seconds to 1.84 seconds. Coming to the user survey results, so high user confidence was there. A survey of 121 participants found high confidence in the blockchain ledger transparency and security provided by multi-factor authentication. So there was a positive feedback. Users gave positive feedback on the interface usability and transaction monitoring features. So, coming to the demographics, the survey included 125, 121 participants, primarily aged 22 to 40, 70 plus 4%, and within an undergraduate education level, 65.3%, high recommendability, total of 88.4% of participants were willing to recommend the digital wallet. Coming to the discussion and overall finding, we have like transaction immutability. The system successfully uses blockchain to ensure that transactions are immutable and tamper-proof. Reliable authentication, multi-factor authentication provides high accurate authentication, which significantly improves the access control. Forward-looking security, integration of post-quantum computing, quantum cryptography provides future-proof security with minimal performance impact. High user adoption potential, high trust and satisfaction scores from user surveys suggest the system is viable for real world use. So these are some limitations in future work. The scalability, the current system faces scalability challenges with high transaction volume. Future work will explore solutions like sharding and asynchronous consensus. Advanced biometrics, we plan to investigate advanced biometrics such as iris or voice recognition to further enhance the security. Cross-chain interoperability, future work will investigate across chain interoperability to extend secure payments capabilities and integration of machine learning into the proposed work. We will further integrate machine learning to detect unusual access behaviors and improve the data sharing efficiency. That's all. Thank you.